Good morning, friends. This is Professor A.K.chaubey here for the Professor Chaubey Physics class under the heading Physics Made Simplest. So friends, today I will be speaking about the interference of the waves, and then we will go further to explain the physical optics, interference phenomena. So we will be talking about the interference. As we know, interference, the English word meaning, to interfere, means if we have one wave is moving, it may be sound wave, it may be optical wave, another wave comes. Then the two waves interact, means the medium is influenced by both the waves. So both the waves are influencing according to the property of the waves, their amplitude, their frequency. The medium will be disturbed and adjusted, and you will get the resultant of the two waves, the interaction of two waves. The media will be displaced and the resultant of that. So interference means the effect of two or more waves in the media, and because waves are moving in a certain media, particularly the sound waves. So whatever the media, how it is disturbed, how we get. So the interference, how we can observe, how to observe interference phenomena. How we can observe, how to observe of waves, how to observe this, and what are the conditions, for sustained interference Sustained means how we can obtain the interference at one place, how we can observe permanently interference, not changing. So sustained, permanent means what are the conditions? So conditions are there should be I now talk about the interference of light because we will talk the light optics chapter. So there should be two coherent light sources for interference of light. What the meanings of coherent means? One is the monochromatic. Monochromatic means wavelength constant. Wavelength or frequency, whatever you can say, wavelength constant. And we will talk coherent also. Monochromatic, that is the source of light. There should be two sources of light. Monochromatic means two sources of light. And there should be monochromatic, means one color. So one color means one wavelength, constant wavelength, and that should be, they should have constant wavelength, so constant frequency, and constant phase difference. Phase is very then the overlapping of the wave will change. If the phase shift is not there, if the phase remains constant, frequency remains constant, you can obtain sustained interference, means permanent. But if the phase is changing, frequency is not constant, you will not. You may observe at an instant, at a moment, you may get interference, then it will disappear. So to get sustained interference, we should have monochromatic, means lambda constant, and coherent sources, coherent means they have constant frequency, they have constant phase difference, they are of one color. These sources are called coherent. Coherent sources, then we can observe the sustained interference. So to observe the interference, we should have these type of sources, the condition of this. Now let us represent a wave by wave equation. So let us represent a wave by wave equation, as we know, we have read. So let us write, we represent waves as the following. First wave y1 displacement is equal to, say, a1 cos omega t plus theta 1. Other wave is y2 is equal to a2 cos omega t plus theta 2. Well, y1 is the displacement due to first wave, y2 is the displacement of the second wave, a1 is the amplitude of the first wave, omega is the frequency constant, theta is the initial phase of the first wave. A2 is the amplitude of the second wave, omega is the frequency, same constant, that is the constant coherent source. And theta 2 is the initial phase, so that is also constant. These two waves are moving in a medium and they are now producing interference. So what the resultant wave is, we can write that according to the principle of superposition, I will not do much mathematics, just I will write according to the principle of superposition of the waves. According to the principle of superposition, what we get? We get the displacement the resultant displacement is given by the resultant displacement at certain time is given by, say, yt at a certain time. It depends, time dependent, of course, time there. y1, y2 resultant is yt, and that resultant is given by a cosine omega t plus theta. You know where we know from mathematical equations that a cos theta is given by, this maybe you can go to the wave motion. A cos theta is a1 cosine a1 cos theta 1 plus a2 cos theta 2. This is from the superposition of the wave and from the sound. And a sin theta is equal to a1 sin theta 1 plus a2 sin theta 2. This is from interference of sound. And the resultant wave, the displacement is given by where A is equal to, the resultant amplitude is equal to A1 square plus A2 square plus twice A1 A2 cosine theta 1 minus theta 2. Yeah, this is the under root of this. That is A1. A. And we have theta, tan theta. I will write here. Tan theta is given by A2 sine theta divided by A1 cos theta 1 plus A2 cos theta 2. Tan theta, I have some, A2 sin theta, yes, and even cos theta. Before that, general tan theta was, we have earlier tan theta is equal to tan theta. Before this, we have tan theta is equal to A1 sin theta 1 plus A2 sin theta 2 divided by A1 cos theta 1. Divided by A1 cos theta 1, A1 cos theta 1 plus A1 cos theta 1 plus A2 cos theta 2. And this, we have modification in this expression. We write that theta 1 is equal to 0 if theta 1 is equal to 0, theta 2 is equal to theta. Means this is the, then we get this thing, A2 sin theta, A1 cos theta 1 plus A2 cos theta 1. Theta 1 is equal to 0, theta 1 is equal to 0, theta 2 is equal to this. Then we have, say, we will like, if this is the condition, then we have A square, A is equal to from this expression, A is equal to A1 square plus A2 square. Yes, A1 square plus A2 square plus twice A1, A2, and theta 1 is equal to 0, theta 2 is equal to, so 0 minus, so this is a cosine, of course, yes, plus twice cos theta 1 under root, twice A1, A2, A1 square, twice A1, A2 cos theta, twice A1, A2 cos theta, and then this is 1 by 2. And this we have some modification that finally we have, tan theta. Tan theta is equal to A2 sin theta 2, A2 sin theta divided by A1 plus A2 cos theta. Now you have, if theta is equal to 0, 2 pi, 4 pi, etc., we get A is equal to A1 plus A2. A is equal to A1, 1 by 2 is here. So if theta is equal to 0, this means 0. This becomes A1 is A1 plus A2 whole square. So A1 plus A2. This means that for phase difference theta, this between two, for phase difference between two waves, phase difference 0, 2 pi, 4 pi, etc. means we have one wave starting like this, the other wave starts from here. So this is 2 pi, pi and 2 pi, or 0 means it starts from here or here, but this remains constant, or 4 pi means after here. So, or it starts from here, that is 0, here 2 pi. This is a pi and this is 2 pi. So this if the phase difference is like this, we have seen that this condition that A, the resultant amplitude is addition of two, that is A is equal to A1 plus A2. And now you see this. So this means addition. Where the phase difference is 0 pi, 2 pi, two waves are having this constant phase difference. The resultant is addition, means it increases, it becomes large. The two amplitudes like one amplitude say here, another amplitude say here, the resultant becomes here. That resultant is A. This amplitude. This was say A1. This was say A2, the 2 becomes here. So A is equal to A1 plus A2. When the phase difference is constant 0 to pi, both waves are in same phase, constant phase. So the maxima of both lies at the same place, so two maxima add together to give addition of 2. And if this phase difference is pi, 3 pi, etc., A will be equal to A1 minus A2. That is this is the constructive. Constructive means addition. This is destructive. So when the phase difference is pi, 3 pi, 5 pi, etc., means wave starts such that one wave is here, other starts say from here, like this. Then these are two opposite. So result becomes, this is A1, this is A2. So A1 minus A2. If A1 is equal to A2 is equal to A, then resultant is 2a and 0. Means the addition of both amplitudes becomes a1 plus a2, both are equal to 2a, and 0 means complete these two opposites, so it becomes 0, or it becomes a1 plus a2, these two are equal. So the resultant is 2a or 0, means this is destructive, bilkul darkness. If it is light, so here maximum, and this is the maximum light, and here's darkness, 0. So two waves interfere like that. You see, when the lambda is the wavelength, here, lambda, this represents 2 pi. Lambda is equal to 2 pi. So lambda, one wavelength, represent 2 pi phase. So when phase is delta, we can write the relation. How? Delta, how? Well, 2 pi is equal to lambda. So what is the delta? Well, delta, phase delta is written as 2 pi over lambda. This is the path difference. This is the phase difference. Delta, yeah. If the path difference is lambda, phase difference is 2 pi. If the phase difference here into path difference, that becomes phase difference. Means the path difference is delta x. This is the path difference. Then the phase difference is. So phase and path are related like this, 2 pi upon lambda and delta x. When path difference was only one wave, the phase difference was 2 pi. When path difference is delta x, this will be 2 pi over lambda into path difference. When path difference is one wavelength, the phase difference is two pi. So from that we get delta is equal to 2 pi over lambda into delta x path difference. Okay. The intensity of the waves depends upon the amplitude, of course. Amplitude is square. We can also write that the intensity I is equal to I1 plus I2 to intensity plus 2 under root I1 and I2 and cosine delta. But intensity depends, of course, upon the phase difference, delta. If delta is equal to, say, that is, say, I, where delta is given here. Delta is 2 pi over lambda delta x, path difference. Well, this gives you us, say, maximum intensity, I max, maximum intensity, when this is the plus term. So that is when this thing is, say, maximum value, cos delta. I max when cos delta is maximum. That is, cos delta is 1. So cos delta is 1 means I is equal to I1 plus I2 under root this. So what do you get? You get I max is equal to under root I1 plus under root I2 and whole square. Understand? And I minimum, when this thing is minimum, that means this is minus. So I minimum is under root I1 plus under root I2. Minimum means minus, of course, whole square. The condition for maximum intensity, how much that this maximum intensity is, the condition for maximum intensity is the delta is equal to 2n pi, where n equal to 0 or 1 or 2 or 3 like this, whole number. Then delta is having this value, the intensity is maximum, this thing. And condition for minima is, for minima, minimum intensity, delta is equal to 2n minus 1 pi. So that maxima of one wave lies at the trough of the other minima. So that is n equal to, again, whole number, 2, 3 and so on. Or delta x, here delta is this means, or delta x is n lambda. Here delta x is equal to n minus 1, n minus 1 by 2 lambda. That is the difference of half wavelength. Here delta x is n lambda, here delta x is n minus half. Means there is a difference of half wavelength. So that maxima falls at the minima of the other wave. So here I is I1, that this is, of course, maximum. you can get I is equal to if I1 is equal to I2, this I1 is equal to, so this becomes 2 equal to I, both amplitude intensity are same, this becomes 2 under root I means 2 into 2, 4I, so that becomes, yes, I becomes 4. This I is the resultant also, so we write here I naught. So this I becomes I1 is equal to I2 is equal to I naught, then I is equal to 4 I naught cos square delta by 2. If you can write if delta is equal to or d is equal to pi plus minus or plus minus 3 pi, then etc., then the resultant intensity will be 0. Here, this cos square, if delta is pi, so this becomes 90 by 2, pi 180 by 2, so 90, so cos 90 becomes 0. The intensity is 0 for this delta. And this is the phase difference actually. This what we have written this here. This is phase difference, delta, that is the phase difference. If phase difference delta is 0, 2 pi, 4 pi, etc., the intensity will be I equal to 4 times I naught, because here we have 4 I naught cosine. So this becomes delta is equal to 0, cos 0 equal to 1. So intensity becomes 4 I naught. So this is the maximum. Intensity will be 0, that I is equal to 0. Minimum. So minimum intensity means darkness completely, maximum is brightness. So we know that condition that the phase difference delta is 0, 2 pi, 4 pi or 2n pi. Delta is equal to 2n pi. Here delta is equal to 2n minus or 2n plus pi. It is like that. Then minima. We know this thing. So this is we can get maximum intensity and minimum intensity for the interference of two waves. Good. Now we have a problem. Problem, so I write, determine the problem, no, we will do problem in the end. This is the interference condition. this is the interference condition. We know that what the phase difference, what the path difference, when the intensity will be minimum, when the intensity will be maximum. Then you know that to observe optical interference, first laboratory experiment is Young's double slit experiment, Young's double slit experiment. What is that? Well, you make one source, two source, convert. You have say one source here, one light source. Here you make two pigeon holes, so that light coming from this here and here. Well, this light here comes out, or goes there, or goes there. So this is the light source. We get S1, S2, or S2 here, or S1 here. One source is converted into two sources. And remember, this is the one source, these two are converted from here. Means source is one, but we make two small holes here, so light coming from here, light coming from here. These two light waves move here and produce in this region on the screen interference. So we have say here the screen. From this or this, we have a screen here. So we can see that light reaching from here, light reaching from here. Meet here. So this light from this source, light from this source. They interfere. And this is the path difference between light. So this was the first experimental demonstration by Young, making two coherent, these are coherent sources because both the sources are made from one source. So this is phase difference constant, frequency wavelength constant. So these two sources are called coherent sources. So Young's double slit experiment, Young's experiment, a simple experiment. Just you have one cardboard, you make two holes, pigeon holes, and put one monochromatic sodium lamp, and this source now producing two sources, and waves moving this side, they interfere because they have constant phase difference, they have same constant phase path difference, or the constant, everything constant, because they are made from one source. Constant frequency, constant wavelength, constant phase difference. So they will produce sustained interference on this screen. This was first simple experiment shown by Young in the laboratory. Well, we can stop here. From here we will discuss some more methods for producing two sources like Fresnel's biprism, and we will discuss details of the Fresnel biprism, etc. So friends, thank you very much.